Hey folks, so in this video I want to talk about operating system structure. So by this what I want to talk about is basically the architecture of kernels, right? So a kernel basically is our heart of operating system, right? With all things that all the low level stuff it lives, right? Obviously, right, there's a lot of pieces to that, right? How do we put them together in a way that makes sense? So here, right, this kind of section is going to call it an operating system structure. Another very typical term would be to call it an architecture. So let's just go ahead and jump in and look at the most simplest one. So this is basically the structure or the architecture, right? Well, on the left I have DOS, on the right I have Unix. These are both what we call a kind of organic or a simple structure. Now this is a little bit of a hand-wavy name. I'm using the name organic because it basically means to me is that we didn't do any planning, we didn't do any design, we just made it work, right? Obviously that's going to be maybe the fastest thing, just to hack it together, right? Or maybe you're building something that's never been built before and you don't know what's the right way to build it. But probably, right, this isn't going to be a well-engineered solution. So let's take a look first on the left-hand side. So this is obviously DOS. So let's take a look at our diagram here. So on top we have the application layer. And I'll call these layers, well, it's okay for me to call them layers, but it's not necessarily a good idea here because we'll have a layered architecture later as well. So just looking at this, right? So at a high level, how are the different pieces put together? First thing we have, right, is this application program layer. So over here. Basically, this is the programs that the user is running, right? So I'm using MS-DOS, maybe I'm using a text editor, maybe I'm playing a game. Those are going to be user applications, right? Those aren't going to be, inside the kernel or inside the operating system. Those are things that I've installed in them, right? So I have those at the high level, right? That's kind of the highest level abstraction here. Then I have, right, some resident system programs, right? So maybe I have something like, for example, an antivirus that is running, right? So antivirus, back in the good old days of MS-DOS, you probably didn't have a firewall installed because you weren't on a network. But you would probably have some sort of antivirus installed, right? So some sort of resident program that's kind of sitting there in the background and monitoring things, right? So a little bit lower level, not part of the operating system per se, not part of the kernel, but still, a little bit lower level than that game that you were playing. Under that, you have basically MS-DOS device drivers. So this is actually your kernel here, right? This is effectively your operating system, right? So your operating system is not really this, multi, program environment, right? Like we're used to with, being on Windows or being on Mac, right? You really, don't have that multitasking environment. You just have one thing going on. Some of the OS's job is primarily to provide this interface between your programs that are running and then the low-level hardware, right? So all these drivers are the main advantage, right? You don't even have, for example, well, if a program is running, right, you don't really have, even a terminal to work with, right? You just have that one thing to focus on. It's just that one program, and the one program is make a whole bunch of system calls to that kernel, and that kernel is kind of using those system calls. Well, it's implementing those system calls, right, based on the device drivers it has available, right, to go and talk to the hardware. Okay. And then the very low level, right, this isn't necessarily the kernel anymore. This is now our hardware, right? So this is kind of our closest to basically kernel over here. Kernel. The very bottom we have the BIOS, right? So we have the basic input-output system. That thing, right, has a bunch of very, very low-level calls, right? This is basically the calls that your hardware directly implements, right? And your OS, right, is going to need to use those, right? So those device drivers that your OS contains, right, typically are going to make calls to the BIOS, right, or either to the BIOS on your motherboard or to a BIOS perhaps on another, add-in card, something like that, right? So this is kind of our hardware level, if you would. So this is hardware versus this is all actually level is all user. I know the diagram breaks it up, but to me, I would consider them both to be user. All right, so this is our overall design. And you can notice that there's these different arrows, right? And these arrows are basically showing how information flows. So device drivers access BIOS, resident program can access device drivers, application program can access resident system program. Actually, it will actually update this a little bit. We'll go there. There we go. Because so antivirus is one thing, but also your OS may have other things that has resident as well, right? So those will be things that are kind of part of the operating system, right, that are more permanent. All right, so anyways, we're showing information flow here with these arrows, right? We're showing information flow. This uses that, right? So application program can call stuff in resident system memory. Resident system memory can call stuff in MS-DOS. Device drivers, that can call stuff in ROM BIOS, so on and so forth. Okay, so this looks pretty well organized, but there is an issue with it. So take 1 second, look at that diagram, see if you can tell what is the problem with this design. So the problem with this design is actually pretty simple. It's that your application program can access the BIOS drivers directly. Okay, so basically, you don't have any kind of level of security or protection from either a malicious program or a program that wasn't written properly, right? Basically, everybody here, right, has all the rights, right? So all my programs can do anything they want, right? They can talk to the BIOS. My system resident programs can talk to the BIOS. Everything can talk to everything. And this is basically a security concern, it's a reliability concern, right? We don't want to have that, right? It would be better if we had things compartmentalized, right? I don't want to run a program, also my computer blue screens, right? I don't want to give it so much permission that it can actually break things. That would be bad. So that's kind of our overall issue here, right? Things have maybe too much, they have too many privileges, right? We're allowed to do whatever we want no matter what part of the system we're in. And so this, right, it works, right, it's okay, but again, right, there's some kind of right sense there that they just kind of need to make it work, and they didn't know how to do it, so they just tried something, right? As we move forward, hopefully we can do a better job. Now, as another quick example here, right, we have Unix. So Unix is another kind of a design here that's sort of organic, right? They would call this more of a kind of a monolithic design. Monolithic basically means we throw everything together in the same pot, right? So there are some sort of layers here, right? So I have, user level stuff, which kind of corresponds to that. I have this, system level stuff over here, which corresponds kind of to this. Then I have kernel level stuff, which corresponds to this. And then some of this basically, there's kind of an overlap here between this and these last two layers here. We kind of have the same level of abstraction, right? We start at very high level user stuff and we work downwards, right? We get more and more closer to the hardware, right? Go from users to kind of the support for users, right? So system libraries, interpreters, etc. Then the actual kernel functionality for making processes run, doing resource allocations, and then down here, right, to the actual talking to the hardware bit. So you have kind of the same hierarchical order, but maybe the concern here is somehow this over here, because everything's just kind of thrown together. And the question is that the right way to do things? Maybe not, right? Maybe we can sort things out a little bit better. All right, so both of these we can consider to be an organic design. They're just kind of things that arose over time. All right, so real quick here, we'll talk about pros and cons to this model or this architecture. So pros, it's fast, right? If you just hack something together, it's going to be easy to put together, right? You don't have to worry about doing all this upfront design. You can just make it work, right? So that's going to be fast. Pros, all right. So fast design, I will write. Fast design. Cons would be basically, it could be unsafe. These are all possibilities, right? Depends on what you actually do. So it could be unsafe. It could be basically error prone. And I'll put this as security here. And last but not least, it's also hard to maintain. Obviously, if you don't, separate parts of your system, it's going to be hard basically to figure out what you need to update. All right, so those are our issues with it. So in this video, right, hopefully you guys have a little bit of a sense, what does this organic design look like? Really, there's no design per se, it's just what happens when you take an operating system and you have to just build it, right? You have to just make it work. So we don't have a particular pattern to follow, we're just throwing things together. In future videos, we'll look at more specific patterns. All right, so I'll see you guys in the next video when we'll start talking about a different type of operating system architecture.